Hi, everyone, and welcome to AXA Arctic Live. It's wonderful to have you all with us. My name is Jamie from Encounter EDU, and welcome to this live lesson on the impact of carbon emissions on the Arctic. And I'm delighted that we are joined by Dr. Helen Findlay from the Plymouth Marine Laboratory. Hi, Helen, how are you?
Hi, Jamie. Doing well, thank you.
Probably a lot warmer than we would be if we were actually in the Arctic rather than virtually there.
Yeah, I think we a little bit warmer, but I hear it's heating up a little bit. The melt's maybe starting, so yeah.
So the melt starting, so that's what we find in late spring where we normally are in the Arctic, and that is in a small settlement called Ny-Ålesund. And that is the northernmost permanent community in the world on the island of Svalbard. And I've got a little globe here, and I'm just going to show you where that is. Hold this up to the screen. So where are we? We have Svalbard is this island here. And as you can see, halfway between the top of Norway, really all the way up to the North Pole. And a few other places you can see around. We've got sort of Greenland here, Iceland, Norway, Sweden, the UK, France, and all over the other side. I think that's there's going to be Canada and the USA. So we're normally based at the UK's Arctic Research Station, and that is operated by the British Antarctic Survey. And from there, we can go and explore and research the Arctic. We're focused on the marine environment. So that means the sea, the ocean that runs past the research station. And over the past years, we've been looking at two things, two human impacts on the ocean. The first one has been plastics. And then secondly, it's been looking at ocean acidification, often known as the other carbon problem. I'm going to be hearing a lot more about that in just a bit. But Ny-Ålesund is a host to many other nations as well. We have the Norwegians here, French, Germans, Italians all have stations here, so research stations. And then researchers, scientists from many other countries come here for shorter periods of time to do their research, to find out what is happening in the polar regions. The format of this live lesson is really simple. We've got some shout outs to give. Then we're going to hear from Helen about the basics of ocean acidification. We have then some pre-submitted questions and some live chat questions we didn't get round to in this morning's session. Please do also put any questions, comments, or shout outs in the live chat box to the side of the video. Now, it is using YouTube, which is a social media platform. So if you are under the age of 13, please make sure that you have a parent, guardian, or teacher who's signing in for you, and then ask them to post any questions, shout outs, or comments. Please do also make sure that these are on topic. This is the live lesson, and it's great to be able to see those on topic comments and questions as they appear, rather than having too many highs up there. Last thing, we just need to see quickly if there are any live shout outs coming through, and then we're going to come through to the pre-submitted ones. We've got some hi Jamies, which is very kind. And then we have, coming on to the shout outs that have been submitted in advance, we have Mount St. Agnes Academy grade 4 class in Bermuda, who are studying climate change and global warming. So hello to all the students from Bermuda. It's great to have you with us. We have a thank you to Dr. Findlay and the Arctic team, and that is from Mrs. Kelly's class in San Diego, California. Hi to everybody in San Diego. And last, we have pre-submitted, we have hi to Garden House School, and that is from Josie and Jasper, who are watching from home at the moment. Brilliant to have you both, and hello also to all the students watching from Garden House School. Fab to have you all with us. So we're going to see just check in on here. We've got Good Maze Primary School coming in as well. So we've got some questions coming through. Just to those of you who are putting questions in the live chat, we're going to be taking those live chat questions towards the end of this broadcast, so we may ask you to repeat them. Don't worry, we do know they're being posted, and we'll get to them as soon as we can. But Helen, we have heard a lot about the climate crisis. For those students who've been following Arctic Live, they may have come across this idea of warming in the Arctic, the sort of loss of sea ice, loss of sort of the ice sheet on Greenland. But there's this other piece that we mentioned in the beginning of this live lesson, ocean acidification. What's that all about, and why do we study it?
Okay, so ocean acidification is sometimes called the other CO2 problem, because as you've said, most people are aware we're emitting carbon dioxide that's going into the atmosphere and causing these warming issues and changing our climate. But what some people don't realize is that the oceans actually naturally take up that carbon dioxide. And they do that, which is really great. They do that by a process of absorbing and reacting with the water. And over geological timescales, really long timescales, that's fine. The oceans are able to absorb that CO2 and nothing really happens in the water because it is what we call it's buffered. It doesn't, the change is absorbed. But when we emit CO2 and absorb it as quickly as we're doing at the moment, so we're worried about the rate, what we're actually doing is creating more hydrogen ions. So I think we might have a visual. So if we add CO2 to water, it reacts, it forms a weak acid called a carbonic acid. And this actually then dissociates, it splits apart to form hydrogen ions and something called bicarbonate ions. And those hydrogen ions, when you add them and you increase the number of those, that makes a solution more acidic. So that's the problem that we're facing today, is that we're adding so much carbon dioxide so quickly that these natural buffering processes can't happen, and we're making the oceans more acidic.
And Helen, you're talking about acid. You're talking about these chemical science sort of terms. What is acidity, and how do we measure it?
So acidity is, we measure it using the pH scale, and you may have come across the pH scale. We measure it in litmus papers, and I think you should be able to see one version of a pH scale where we go from 0, which is the most acidic, and that's things like battery acid, and that's got the most amount of hydrogen ions in the solution. And you go right through then to 14, which is the most alkali or basic, and that has the least amount of hydrogen ions in. It's got much more hydroxide ions, which are the other part of water, hydroxide and hydrogen ions. And that's things like you can get bleach, and cleaning products tend to be alkali. In the middle, just like a temperature scale goes from minus whatever, minus 20, 50, 100 to positives, in the middle of that is 0, and the decision to have 0 was based on what pure water temperature freezes at. Just like that, for the pH scale, pure water has a hydrogen concentration that's in balance, so that's hydrogen and hydroxide ions, and that's called neutral, and that's pH 7, and that's bang in the middle of the scale. Seawater is actually around about pH 8, and so 8.2 at the moment if we're looking at global averages. And so we're talking about, with ocean acidification, we're talking about going from a slightly alkali to slightly less alkali, but it's actually still increasing in acidity, so we call it ocean acidification.
Brilliant, Helen. And the thing I always find very confusing with this is that an increase in acidity is a decrease in pH. And just remember, that because we talk a lot about, when we're talking about changes, we're talking about maybe the acidity is increasing, but that means for those watching is that there's a decrease in pH. We've talked a little bit before about this relationship between atmospheric carbon dioxide in the ocean, and then pH. is this something that is changing at the moment? Can we sort of, have we recorded this change?
Yeah, so one of the things that's very clear is that we can measure carbon dioxide in both the atmosphere and the water and the pH as well. And we've been able to measure carbon dioxide in the atmosphere. One of the most famous long-term stations is in Hawaii, Mauna Loa Station, and that's where a lot of our early data comes from. And there should be a visual on screen now which shows that the red line going through time is the increasing atmospheric CO2 concentration. Alongside that, actually, around the world now, we have many marine stations which are also monitoring the ocean carbon dioxide levels. And you can see that on this figure with the dark blue line. It's a bit more wavy because there's a bigger seasonal cycle in the oceans than there is in the atmosphere. And the light blue line actually represents the seawater pH. So that's showing the decrease in pH through time corresponding to those increasing CO2 levels.
Brilliant. And so we've got this chemical or change in ocean chemistry, this decrease in pH. Is this something that we should be worried about, or is it great that the ocean is taking carbon dioxide out of the atmosphere?
It is fantastic that the ocean is one of our key sinks. It's taking up this carbon dioxide from the atmosphere. Without that, the atmosphere would actually be a lot warmer than it currently is. But it's this rate of change that we're really worried about. And because it's happening so quickly, and we haven't seen those sort of levels of rates of change for at least 600,000 years. And so creatures and organisms that live in the sea have evolved in very stable pH conditions. And so we're worried about how they might be able to respond to these changes, these rapid changes.
And both you and Kerry, who's also a member of the Arctic Live science team, who's looking at the plastics piece of work, your work is focused on what are called zooplankton, tiny animals that live in the ocean. Why has your work focused on these types of creature?
Well, we're interested very much in the lower ends of the food chain. So phytoplankton's right at the bottom for most of the marine food web, which is the plants of the ocean. Without them, we wouldn't have half the oxygen that we're breathing today. And zooplankton are those things that feed on those phytoplankton. They're the consumers. So particularly for ocean acidification, we're interested in the zooplankton that are very abundant, that a lot of fish and other animals eat. So things like copepods you may have heard of if you've been following some of the lessons, and pteropods are something that we're interested in, particularly with ocean acidification, because they have a calcium carbonate shell, and we haven't really mentioned them yet, but calcium carbonate actually starts to dissolve in more acidic conditions. So that's something that we're concerned about as well. And if we lose these middle sort of level of the food chain, then we're going to have impacts up higher into the food chain, such as walruses. I mean, they eat shelled organisms, mussels and oysters and clams. And a lot of the fish rely on things like pteropods. Salmon relies on pteropods. So if we lose some of those, or we see changes in those food webs, then that can have knock-on effects right up to the top predators.
So how we're talking about, I think, to use a science term, primary consumers, and especially those primary consumers. So those are the first level above the producers. So we've got the producers, the algae in the ocean, and then the first level, just to review that science language, the primary consumers eating those algae. A lot of them have this sort of calcium carbonate shell or structure. What is the sort of, is it biochemistry that's going on that's affecting them, and is it something that you can see?
So when you're adding CO2 and it's creating the more acidic conditions, what it's actually doing is changing what we call the carbonate system. So shells and structures made of calcium carbonate in particular, so that's things like mussels, oysters, clams, corals, crabs, all of these creatures have calcified material, calcium carbonate material. they actually try and they actually dissolve in really acidic conditions. So they're trying what they're trying to do is give away their shell to soak up those hydrogen ions, to soak up the acidity, in a very chemical sense. But because they're living organisms, they actually can counter that. They can use energy to build new shell, and they can use energy to produce new material and to fix their shells and repair their damage. So ocean acidification it's not going to be an extreme change in acidity, but again, because we're seeing this long-term change, and at a much faster rate than we've ever experienced, we're concerned that some of these animals are starting to feel the impacts of these, and actually see detrimental impacts on some of these shelled organisms.
So I think I don't know, we've been able to see some of under the microscope the sort of pitting on, I think it's a pteropod shell from the Beaufort Sea. And there are sort of, you've got a sort of under the microscope, I think sort of 4 images. Are these different conditions, or are these just different individual examples of pteropods?
It's slightly different conditions. These are examples from the Beaufort Sea, as you've said. So in the Arctic, above the kind of the Canadian, Alaskan Arctic, and these are from present day. So you can actually observe corrosive waters in the Arctic during certain seasons of the year at the moment, which is because of acidification and because of the conditions in the Arctic. And so you can go out and collect these shells and pteropods and see these pitting and damage to their shells. So you can see the first one at the top. I don't know if you can see there's letters A, B, C, and D, but they go from order at the top left down to the bottom right as extreme of corrosive conditions that they've been experiencing. So those are real pteropods that have been exposed, not in a lab, just in the field that we've collected.
Wow, so it's something. It's not one of these sort of, this might happen. It is already happening.
Unfortunately, so yeah. The current levels in the Arctic are particularly worrying. So it's something that is happening at the moment. Yeah.
And Helen, you go to the Arctic to study this. I just want to sort of ask you a little bit about what it's like studying in the Arctic, working as a scientist in the Arctic, and perhaps start off. I think the first time we met was on the sea ice off Canada, and you spent a lot of time in a sampling tent. I think we've got a photograph of you with a sort of purple gloves and what looks like a sort of a bit of drain pipe. What's going on there?
So that's that was in the Canadian high Arctic. That was taking water samples using what we call a Niskin water bottle, which is a special oceanographic tool. There's 2 or 3 really key tools, bits of kit that we use when we're sampling for ocean science. This is one of them. It's called the Niskin bottle, and it has 2 ends which open up, and then we put it down on a wire to the depth that we want to collect water samples at. And then we can send down what we call a messenger, which is essentially just a weight, and it triggers the bottle to shut the lids, and it captures that parcel of water. And then we bring that parcel of water up to the surface, and you can see here I'm then draining off that water into individual collection bottles, which we then take away to measure the carbon dioxide levels or any other nutrients or chemicals that we want to measure.
And Helen, I think we have a photograph of your sampling hole with a visitor. So it's not only water samples that you find in a sampling hole you drill and dice, but I think we have maybe sort of a strange visitor. And what happened that day?
There was particularly strange. We had these tents in the high Arctic. We had tents covering these ice holes to try and stop them from freezing over, because we wanted to go back and repeat sampling. And every now and again, we'd go to the tent and we could smell this really sort of quite strong fishy smell, and we didn't know what it was causing it. a bit confused. And then one day we were actually taking a sample, and the equipment is actually down the hole, so you can't see it in this photo, but all of a sudden this seal crawled up the edges of the hole, and it had obviously found our hole and was using it as a breathing hole. And it's interesting, the difference actually between seals in the Arctic and the Antarctic. Seals in the Arctic are very, very cautious when they come up for air, because they're obviously not wanting to get caught out by a polar bear. In the Antarctic, they just jump around and flop up and get onto the ice and don't have to worry about it. So it was a really amazing experience to see this seal pop up our hole.
Brilliant. Thank you, Helen, so much. I mean, there are some other images of fieldwork, but just before we get on to the questions that have been submitted, I'd love to share this amazing footage of what lives under the ice, because here in the Ollesund, it all looks very white and sort of almost desolate, and yet there is life under the ice. And I think you've got some clips for us from up here.
Yeah, so I think you should be able to see a video of some of the Kongsfjord, which is just next to Ollesund. This was in 2009, and the fjord was actually fully frozen, and we had to cut a hole in the ice and then send divers down underneath the ice. And I think this should be video footage of a spider crab. And then also following on from that, there should be video of a pteropod, which is one of these shelled organisms, these sea butterflies or sea angels. And we were using the divers to collect the animals, which we were then using in experiments to test to see how well they can survive changes in pH and acidity. And the divers have to go up and down in these ice holes, as hopefully you should be able to see on the video.
Brilliant. I mean, thank you so much for sharing sort of the basics of ocean acidification, how it's affecting life in the Arctic, and then a little bit about the sort of the ins and outs of field work. We have a lot of questions, and a lot of them are sort of like very, very interested in just general Arctic questions. I'm going to come to those in the live chat first, but I've just got some clarification questions that have been sent through on ocean acidification. The first question is fresh water affected by acidification as well as seawater or salt water?
So, yes, it is. Many of you are probably too young to remember the acid rain issues that we had back in the 80s and 90s, but that was mainly, it was kind of a different issue because we were adding a different kind of acid. But fresh water, like any solution, can actually have acid added to it and be impacted. So fresh water can be affected by acidification. Fresh water doesn't have the buffering system that the seawater has. It doesn't have these carbonate system that the ocean is able to absorb lots more carbon dioxide because of that carbonate system, which fresh water doesn't have. So fresh water actually gets acidic much more quickly than the oceans would do.
Brilliant. Thank you, Helen. From Ferdors from Fursdown Primary School is asking how much carbon emissions are produced each year. What are we talking about here?
I think the latest figures for last year or the last few years was about 36 billion tons of carbon per year. It's difficult to put that into perspective. I think it's either the NOAA site or there was a really good website that actually did some demonstrations of what a block of CO2 would look like that size, and they put it in full into the New York center of New York Park, and it went up about 8 kilometers into the sky, the size of New York, something like that. I can't remember exactly details, but it's a lot of carbon dioxide, and I suggest you go away and have a Google and see if you can find those visuals.
Brilliant. So a huge number, and do try and find some of the data visualizations on that online. We've talked about pteropods, we've talked about animals with carbonate structure skeletons. Does the pH change affect Arctic mammals and their internal processes. So do they find it harder to regulate?
Mammals probably not so much. We're not really concerned so much about their direct impact from pH because they have a lot of internal processes that are able to buffer any change in pH. So they're not really affected by the seawater pH directly. It would be the same as it affecting us. It doesn't really affect us. You can still go swimming in the sea and it wouldn't affect us. We wouldn't feel any impacts of that. We are concerned about how they maybe are affected through the food web, but not directly, no.
Brilliant. So can we come on to a question from Tamsin Clements? We saw that photograph of the shells corroding. How long does that process take? And how long does it take for shells to corrode enough for it to really affect them?
It kind of depends on the level. So if we've got extreme levels, it can happen within days, maybe 2 weeks, 14 days. Would get to a level where they're quite severely impacted. But generally, we're talking a few months. And if you think about the Arctic, the seasonal cycle of the Arctic, those sort of pteropods are being exposed at the moment in those extreme cases to corrosive conditions for perhaps just 1 or 2 months of the year. And the impacts that you saw are a result of that. So we're talking about weeks to months, really.
Thank you, Helen. From Reese Parker, we have which animal is most in danger over the next 10 years? And I think, probably focus on the Arctic and why. If we can.
If we're talking just about acidification, I think we have to think really that these things like pteropods are probably going to be severely impacted, but also things like the early life stages, so the larvae of things like clams and mussels. In the Arctic, they're really important as well as part of the food chain. And what we're finding is that the really young stages of these life cycles are also quite severely impacted. So that's where we're kind of trending to focus our research because we know that they're more likely to be affected. So I wouldn't really put my money on one specific animal. There will be winners, there'll be losers. But I think for the Arctic, we have to think about pteropods as one of the most endangered.
Right, Helen. We have a sort of a bit of a quick fire round here for a lot of questions coming in. We have from Nelia Duarte, how cold can it get in the Arctic, or what's the coldest that you've experienced?
The coldest I've experienced is -57 with wind chill, I think. So I think it was about -48 still air temperature. Pretty cold.
Yeah, I do remember that day. That it was painful. Username Liam Jones would like to know how much food can you get in the Arctic? Where do we eat?
In Nørresund, we have a really lovely communal area called the mess area, where we have a lovely set of kitchen staff that cook us delicious meals. It's a bit like your school canteen, and they have a big supply of food that gets sent up in ships primarily from Norway and stored up there. And then in the summer, they can get more frequent food in through planes, but mostly it comes through ships.
Thank you. Very tasty it is too. Username Kellen Sook would like to know what's the newest species you have found. Are you, because some scientists go and find new species, or is that part of your role, Helen?
No, I'm afraid I don't tend to look for new species. I am much more involved in trying to understand how the environment and the species that we know about, how they interact and how they change together. So I'm afraid I can't give you an answer for that.
Okay. Well, brilliant, but interesting question from Kellen. Username Cassia Murbach would like to know how long can it take to get frostbite? And speaking from personal experience, Helen.
From personal experience, I would say within minutes if it's really cold enough. I managed to get frostbite in the tip of one of my fingers while trying to undo a zip. The zip was metal and was very cold. I stupidly took my glove off and it froze, and then was very difficult to warm up again. I spent the night in a lot of pain with my finger, and then it recovered for about a month afterwards.
So be careful if you're in the cold places. Chocolate Man 31 would like to know how many animals live in the Arctic.
Quite a few, probably more than you think. I can't give you the exact number of animals. We see a lot of reindeer up in Nylsons. You do obviously get polar bear, Arctic foxes, lots and lots of different types of birds. I'm not a bird person particularly, so I can't name them all. And then there's a huge amount of marine life. Everything right through from phytoplankton, the plants, which aren't technically animals, but we like to include them. Zooplankton, right up to crabs, whales, dolphins, not so much maybe in the Arctic, narwhals, and walrus, ducks.
Sharks, I was saying. Eider ducks and Greenland sharks and eider ducks.
Greenland sharks.
So lots and lots. It is much more diverse than perhaps people think. Justin Franco would like to know, do animals without fur freeze to death?
I would imagine that if there are animals in the Arctic without fur, they probably have got some other mechanism to keep them warm. But yes, if you took up a naked hamster into the Arctic, it might well freeze to death.
Brilliant. So we have animals adapted. So there's various adaptations that we see. As you pointed out, fur is one of them. Blubber is another. So have a look at the blubber gloves activity on the Encounter EDU website. And my favorite adaptation is the Arctic cod with its antifreeze in its blood, I think. Various adaptations that animals have. Justin would also like to know, can animals get frostbite?
Yes, I would imagine there's no reason why they couldn't if they didn't keep warm. Yep.
Okay, there's a small question here. This is from Oscar. What's the most damaging human-caused event that will affect the Arctic?
If you lump it all together, then emitting CO2 is a pretty bad one. So we're causing quite a lot of trouble with that. The Arctic, things like shipping and can have a big impact. But I would say I would go with the CO2 emissions causing lots of changes.
So we have questions on that. It is really that we've got a couple of questions or three about carbon emissions. You showed the graph; we can see them rising. We know about the climate crisis from the news and from scientists feeding into those reports. Three questions are. This is from San Diego. How can we reverse the carbon dioxide damage? Ernie's asking, are you hopeful we can reverse human damage, and that's on the oceans? And then we'll come on to Eloise's sort of niche solution in just a bit.
Okay, so reversing it, yes, we can to some extent. We need to really dramatically reduce our emissions, and we need to do it as soon as we can. And that will allow temperatures to stabilize, and it will allow things like pH to stabilize. We're already locked into a certain amount of change because things happen in the atmosphere and the oceans on much longer timescales than sort of day to day or year to year. It happens over tens of years to hundreds of years. So we're already committed to a certain level, but we can certainly stop the worst case scenario. And if we want to actually reverse the damage, then we need to start actually taking out carbon dioxide. So using technological solutions to bring carbon dioxide back down to pre-industrial levels, which is a bit more of a challenge and is probably something that's much further down the line. But I am optimistic, I am hopeful, and I think there's some recent examples that show that we can start to change, and we are starting to change, albeit a bit slow. There's been a reduction in coal emissions, which is great. The energy sector part of emissions has been relatively stable the last couple of years. So CO2 emissions are starting to stabilize and reduce. And that's because energy is now starting to become more common to become from renewables. So I think up to about 28% of renewables over the whole globe provided the energy that we used over the whole globe last year, which is fantastic. So we are moving in the right direction. We just need to be perhaps a little bit quicker about it.
Helen, thank you very much. So the direction of travel, we can do it. A lot of people were reflecting on their relationship with nature during lockdown, and some very positive news there from Helen, sort of showing how we can build on successes, particularly in the energy sector. People can consider changing to a renewable energy supplier at this time. I just want to go some questions here from Mount St. Agnes Academy in Bermuda, which I'd love to talk to you about. So what do you see? What can you see in the Arctic that shows signs of global warming?
I think one of the most obvious signs is the changes in the snow and ice conditions, particularly in Svalbard. We're on the west coast, and there used to be a lot of sea ice coming down that side of Svalbard, but there really hasn't been a significant amount of sea ice in the area since perhaps 2006, 2007. So that's been a big change. And the other thing that's a big change in the Arctic is that there's been more rain rather than snow. And that's a big issue. We got a surprise rain event back it was either 2010 or 11, I can't remember which, when it was, we were expecting conditions to be -30, -40, and it was above zero for a period of the time. We were out on the sea ice, and that's quite a scary prospect to be stuck on sea ice when it starts to rain. It's also a big problem for things like reindeer, where the rain happens, it freezes over, and then the reindeer can't access the grass or the ground below that, whereas normally it would be covered with snow and the grass would be easier to get to. So I'd say those two are the biggest issues that we've actually visually been able to see changing through time.
No, I mean, it is very strange when you get rain in the Arctic in March, where it's below freezing in most of the UK. And yeah, I mean, just those sort of that impact on wildlife, including on Arctic foxes as well, and in terms of,
Yeah.
sort of the animals local to where we stay in the Arctic. And this leads us on to, how difficult is it for animals in the Arctic to hunt for food due to changes from global warming, and what can we do to save the animals from becoming extinct? Again, from Mount St. Agnes Academy.
Well, I think the changing environment is providing a challenge for a lot of animals. Many of them are finding new ways to look for food. Things like polar bears we hear quite a lot about, but if you speak to some of the people that study them, certain populations are doing okay. They're finding new ways of getting food. But it is causing a lot of problems. For example, the foxes and the reindeer are finding it harder to get food in the sort of the melt season, at that time of change between when it is all frozen and when it's summer period and you get these rain events happening. What can we do to help them is really, I think the key thing for most of us is to try and find ways to reduce our emissions, and that will have bigger impacts on a larger scale. And we need to think about how we look after the environment and try and not put waste into the environment, try and minimize our impacts in other ways. So things like fishing, pollution, they can be managed much more easily, and we need to be able to try and help those other things to provide a safer, cleaner environment that is much more manageable. And then these global issues such as emissions can be kind of help the animals on top of that.
So really, I mean, the main message I'm hearing here is we have to deal with our carbon emissions. That human activity is driving a lot of change, and that's all of our responsibility.
It is, and it comes down to all of us, and even if it's the little things. We talk about just like switching light bulbs off, but being aware of the energy you use, where your energy is coming from. I know a lot of the children, obviously, you don't choose your electrical suppliers or anything, but you can get renewable source energy suppliers, and we can, as citizens, we can put pressure on our governments to change by showing where we want to buy things and showing where we want to put our money. And so if we all went and bought renewable energy suppliers, the renewable energy industry would have to react to that. They would have to say, well, we need to supply more energy. It needs to come from renewable sources. But even things like if you want to ride to school, if you can ride or walk to school rather than go in the car, then that will make a big impact as well. Just these small things will make a big difference. It might not seem like it, but it all adds up. And so on an individual level, we have a responsibility, and then the businesses, big corporations and governments also have a responsibility to react as well.
Thank you, Helen. It's an incredibly important message, and as we near the end of Arctic Live, it's wonderful to be able to share the passion that Helen has and her experience and the sort of advice. Helen, if I could just end this live lesson on a few things. What's your favorite Arctic experience so far?
Oh, I don't know if I could pick one, but I guess one of my favorite memories is in 2010 when we were up on the Canadian sea ice. I think you were on that trip, Jamie, and we were supposed to be going to bed, but the sun was just at this amazing angle that all you could see was sort of pink and blue, baby pink and baby blue across the ice. And I think a number of us just sat outside our sleeping tents watching the gentle wind blowing the drift across the ice and snow with these amazing colours. And I don't think I will ever forget just sitting there in that quiet, just isolated space watching that beautiful scene. So that's probably one of my favourite memories.
And we've got a question through here in terms of sort of favourite type stuff. What is the most important bit of kit that you take with you to the Arctic?
Cable ties and duct tape.
Brilliant. I do have that, and quite often have it in my carry-on when I'm going on expedition. And airport security normally takes a fairly dim view, so I'm now making sure I get that in my hold luggage. What we haven't been able to go to the Arctic this season. What do you miss most about the Arctic?
I think there's a couple of things for me about the Arctic that I love. There's some kind of addiction I have to it that it's very difficult to explain, whether it's the isolation, the experience of being able to find out new information that other people haven't been able to find out before, and just see and experience something that we're very privileged to be able to do. And the other thing I think for me is these expeditions are very much about the people that you go with. We're very much isolated with a small group of people, and generally speaking, it's an amazing group that gets on. You're all kind of very like-minded to go on these sort of expeditions, and it's because they become family where you're away with these people for well, sometimes quite short periods of time, sometimes up to 2 months or so. and it becomes like you're a little family. And so, as much as anything, it's the people that you go on these trips with that I miss as well.
Helen, thank you so much. We're nearly at the end of this live lesson, and indeed Arctic Live for this year. You are an truly inspiring scientist and person. You have got frostbite in the pursuit of data that's helped people to set policy and understand their changing world. You've brought temperatures down towards -60. You've wrestled with zooplankton, all these incredible things. What message would you give to young people wanting to follow in your footsteps?
Pursue your passion. Obviously, you probably need to work hard, but work hard at whatever you enjoy doing, and never give up if someone tells you you can't do something. I think for me, that's always been the biggest driver in a way, is if someone says I can't do something and I really believe I can, as long as it's a good thing to be doing, then I try and prove them wrong. I was 11 when I decided I wanted to be a marine scientist, didn't have a clue what it involved. And one of my teachers, I don't remember which one, told me that it was very competitive and I'd never make it. And I'm sat here now in front of you telling you that if you really want to, you can. Just do the things that you're passionate about, stay passionate about them, because that comes across as much as your knowledge does. Knowledge can be gained, you can always learn new things, but you can't always learn new passions. So keep that passion.
Brilliant. Helen, thank you so much. And thank you so much to all those of you who've been watching and joining us for AXA Arctic Live over the past 2 weeks. And just hearing Helen there, I mean, I think that those sort of 3 core messages is what I hope you've taken away from Arctic Live. Stay curious and passionate, never give up, and make a difference. You have been amazing, and a big thank you at the moment to AXA, who've supported Arctic Live, to the British Antarctic Survey, who are normally our hosts up into Arctic, to Helen and all the other speakers. And we've had Clara, Nick, Chloe, and Kerry, and of course to Ellie behind the scenes producing, and to Sim, who is moderating. And so I won't normally have seen either of them, but they make a huge difference to how this runs. It's been fantastic having you. Until, fingers crossed, next year when we might be up in the Arctic for Arctic Live, we will be putting on more live lessons between now and then. We've got, of course, got Coral Live in November. But until the next time, thank you so much for joining us. Bye-bye.